Every year, millions of tons of fruits and vegetables are not harvested by hand, but by machines operating with precision measured in seconds. Miss the timing by even a single beat, and an entire field can lose its value before it ever leaves the ground. That is why modern agriculture has transformed farmland into mobile, open-air factories. From delicate leafy greens to fruits weighing tens of kilograms, every crop forces machinery to completely change how it operates. And the fascinating question is this: how do these machines actually manage to do it? In large-scale lettuce-growing regions, self-propelled harvesters are designed to operate continuously across flat fields, where the time immediately after cutting determines commercial quality. Lettuce harvesters typically operate at speeds of 3 to 5 kilometers per hour, fast enough to meet tight harvest schedules while maintaining blade stability and conveyor control. The price of a specialized lettuce harvester currently ranges from approximately $120,000 to $200,000 US, depending on the cutting system, cooling features, and integrated bin loading. Globally, lettuce production exceeds 27 million tons per year, with China, the United States, and Spain among both the largest producers and consumers. But once the machines leave these light, short-cycle, leafy green fields, they are about to face something far heavier and far rougher. Pumpkin harvesting presents a completely different challenge, where machines must handle heavy fruits distributed unevenly across the field surface. Pumpkin harvesters move more slowly, typically around 1.5 to 3 kilometers per hour, to ensure the safety of the gathering arms and heavy-duty conveyor systems. An industrial pumpkin or squash harvesting system can cost from $180,000 US to well over $300,000, depending on sorting capabilities and bin capacity. For this crop, machine efficiency lies not in high speed, but in maintaining stable traction and safely handling each pumpkin weighing tens of kilograms. After completing fields filled with pumpkins weighing tens of tons, the machines are reconfigured for a completely different task: harvesting spinach. Spinach harvesters operate at higher speeds, with cutting blades positioned extremely low, just 2 to 4 centimeters above the ground, to capture tender leaves. Vacuum-assisted lifting systems and lightweight conveyors raise the leaves without tearing or damaging their delicate edges. A mechanized harvesting line can process 10 to 15 tons of spinach per hour, meeting the demand for rapid harvesting to preserve freshness. For this crop, machine success is determined by blade sharpness, travel speed, and the ability to preserve the structure of thin leaves. Once the light spinach beds have been cleared, the machinery moves on to a crop with a far thicker and sturdier structure. Cabbage harvesters use high-powered rotary cutting blades, precisely adjusted to cut close to the base without damaging the outer protective leaves. Heavy-duty gripping systems and reinforced conveyors hold each 2 to 5 kilograms head firmly, transferring it into bins without deforming its commercial shape. A single harvesting unit can collect 20 to 30 tons of cabbage per hour, maintaining steady output across large fields. Here, efficiency is defined by cutting precision, gripping force, and the ability to handle each head uniformly. After completing leafy vegetable fields, the machinery is reassigned to a completely different crop type. Harvesters use hydraulic shaking mechanisms that act directly on the trunk, with vibration cycles lasting just 2 to 4 seconds, enough to dislodge ripe fruit without damaging branches. Vibration amplitude is flexibly adjusted based on tree age and wood stiffness to avoid biological stress on perennial plants. Catch frames and fruit collection conveyors operate in sync, allowing the entire process to run as a closed cycle lasting less than 30 seconds per tree. For this crop, efficiency is not measured by travel speed, but by vibration, precision, and mechanical synchronization. From rigid woody trunks, the machinery is once again reconfigured for a crop requiring even finer control. Harvesters operate at a fixed height, with cutting blades calibrated to within just a few millimeters to separate florets from stems without cracking floral structures. Soft gripping systems hold each head for only 1 to 2 seconds before placing it gently onto padded conveyors. The entire sequence, cutting, holding, transferring, and releasing, is completed in one continuous motion with no intermediate stops. Here, machine performance is defined by motion stability, blade accuracy, and the ability to maintain perfect repetition. After delicate leafy beds, the machinery enters a much more demanding challenge. Onions, bulbs positioned near the soil surface that require precise digging depth and all-day consistency. Mechanization studies report onion diggers operating at around 3.0 kilometers per hour, with average fuel consumption of approximately 4.10 liters per hour, depending on machine configuration and field conditions. On the market, some use self-propelled onion harvesters may be listed at around $85,000, though actual prices vary by year, operating hours, and condition. Globally, onions are the undisputed king of volume. India alone produced approximately 37.1 million tons in 2022, with average per capita consumption reported at nearly 14 pounds per person per year. But once the machinery leaves the high-friction soil of onion fields, it must transition to a completely different suspended environment, kiwi orchards. With kiwi, instead of digging and screening, mechanization focuses on elevated platforms, soft conveyors, and collection systems that work within narrow trellised canopies without scuffing fruit skins. while more advanced mechanized harvesting systems can reach around 155,000 US dollars, depending on machine type and purpose. On the market side, Zespri reported approximately 220.9 million trays and over 5 billion US dollars in global revenue for the 2024/25 season, highlighting just how intense harvest optimization pressures have become. In terms of national consumption, market reports identify China as the world's largest kiwi consumer at around 2.2 million tons, approximately 52%, during the reporting period, with recent trade data also showing China as a major import destination. Because kiwi is both skin-sensitive and part of a long export chain, every machine parameter, from platform stability to conveyor materials, is designed to preserve fruit appearance from the very first second it leaves the trellis. After suspended fruit orchards, the machinery is deployed again in low trellis vineyards, where narrow spacing demands extreme precision. Self-propelled grape harvesters move between rows at approximately 4 to 6 kilometers per hour, using vibration mechanisms to detach ripe berries without destroying cluster structure. A modern grape harvester typically costs between 250,000 US dollars and over 400,000, depending on vibration systems, cleaning modules, and conveyor design. Kale harvesting requires machines to operate extremely close to the ground with high precision, since the entire commercial value lies in the leaves. Kale cutters operate at speeds of approximately 2 to 4 kilometers per hour, with blades stabilized to cut stems cleanly without tearing leaf edges. The price of a specialized leafy greens harvester typically ranges from 90,000 US dollars to 150,000, depending on conveyor and cooling systems. In market terms, kale is heavily consumed in the United States, the United Kingdom, and Germany, with the US leading in per capita kale consumption. For this crop, machine efficiency is not about raw power, but about preserving leaf shape and maintaining quality within minutes after cutting.